Hi everybody, let's talk CLI today. While many people try to bury the CLI, we at SR Linux understand its importance, especially during the troubleshooting or some operational tasks. So instead of saying that you need to go full speed API driven mode and do not touch your CLI, we think that you should have both great CLI and great APIs. So today we will talk about the great CLI part, and especially the CLI customization and the CLI programmability that we offer at SR Linux. So what you're looking at is two SR Linux nodes running next one to another. One is called CLI is King, and the other one is just SR Linux. Now, if I want to feel like home, even though my home might be a shabby cardboard place, I can type show IP route VRF management on the CLI King node, and look at this. This is actually feels like home to many network engineers. And at the same time, this CLI command runs on SR Linux. If I type it on my SR Linux on the right-hand side, show IP route, there is no such command at all. So what happens here? How does this node have the CLI command and this one doesn't? It all comes down to the CLI customization and the CLI plugin infrastructure that SR Linux has. So let's dive into the customization part here and explore the SR Linux CLI and what you can get with it. Now, the first part, of course, is why would you want to write your custom CLI? Well, it might make sense for you to operationally have a custom CLI command that does a specific thing for you and for your team. You know that if your custom CLI command is quite specific, there is no chance it lands into the native CLI tree of any operating system. It will just not be feasible for every other customer. That is why having the customization that makes sense to you is of utter importance. If you have the plugins and infrastructure that supports you to create those custom commands that feel basically indistinguishable from the native commands, your hands are untied and you can create the best operational experience for your team. So let's see how we implement this in SR Linux. The CLI engine in SR Linux is actually an open source Python-based project. You can have a look at the source code from the SR Linux CLI file system and see how we implement native commands. Our CLI engine allows you to customize commands in 3 different domains. The most important one probably is the show commands. These are your show version, show interfaces, show network instances, BGP, etc. And you can create those plugins in the show command tree that would make sense to you. Maybe you need to have, I don't know, stock options in your CLI. You can write a show stock options command. But of course, a more feasible example would be to list ports or network instances that you have created for yourself and make them look and feel the way you want them to be. You can also create the global commands, and these are the commands that kind of operational. It's your pings, trace routes, listing files. Maybe you want to create a git command on your CLI and interface with a remote git repository. You can definitely do that as well. And lastly, the third block that we allow you to customize with SR Linux CLI is the tools commands. These are the commands that kind of run to completion tasks that you want a system to perform, like reboot a chassis or bounce the interface can be a custom command for you. So you can customize with plugins all of these different trees of our CLI and have the experience tailored to your operational teams. So I wanted to take you on a journey of writing our own show command. And through this exercise, you will understand what it takes to write a show command of your own. We will have a simple example in front of ourselves. We will write the CLI command that will show the current uptime of our SR Linux system. Now, the way to approach the CLI plugin development is, of course, to take it slowly, step by step, and we will do that together right away. All you need to have is the container lab installed on your system and have Git, which is probably already installed on your machine or on your VM. So we'll leverage these 2 simple prerequisites before we start. The plugin that we will write with you today has been already written, and it's part of the repository that we have put online in our SRL Labs GitHub organization, but I will start from the ground up. So we have this GitHub repository, uptime CLI plugin. So I need to clone this repository, and let's do this together. So I just go to this clone menu, then I go back to my terminal and I do git clone and paste the URL. Now, once my project is cloned, let's dive into it. So it's called Uptime CLI Plugin, and we will take it from here. Once we are in the Uptime CLI Plugin cloned repository, I want you to check out to the Get Started branch, because in the Get Started branch, we have a bare template for the CLI plugin. We do not want to have the already written CLI plugin and look at it and kind of discuss what's going on. We want to write it together and see what it takes. So we do git checkout get started. And once we are in the Get Started branch, we can open our favorite IDE editor and see what is part of this project. When you open this project in your favorite IDE, you will find some certain file that you probably will recognize. So first of all, we have the ContainerLab lab that is part of this repository, because we want to create a development environment and as well test our CLI command right away. That is why ContainerLab with a single node lab will help us here. We'll have this Nokia SR Linux container image created for us, and we will also create a bind mount of the uptime CLI plugin that we are going to write together that is kind of mounted to this path where the CLI engine expects to find custom CLI commands. You also have the run shell script that has kind of the simplified steps for you to leverage when you want to set up the development environment, because it's quite important to have a nice code auto completion, see your IDE not throwing errors at you because of the failed imports. You want to have the Python of the certain version installed to create these CLI plugins, and this run command runner actually helps you to set up these necessary prerequisites with a single command. All right, so let's first start with setting up our development environment. In this run script, you will see that there are some dev env functions. And one of the interesting or the top level command that you would like to run is setup dev env. So now, because I already have UV installed, you will not see how we install the Python. It's already there. We will just starting building up the lab, and maybe like 15 seconds later, we will have the full lab running, and we will also install the virtual environment with all the dependencies that our CLI plugin requires to have. Now, as you can see, it's been probably like 20 seconds on my machine to prepare the full development environment. Now I can go back to my IDE and start actually writing code. Okay, now that we have created the dev env, we can see what is the entry point for our CLI plugin. If you look at this uptime directory, you will find the uptime Python file inside of it. That is the starting point for us to write our CLI plugin. The way the CLI plugin infrastructure works in SR Linux is that you have to create just a single file that has a class plugin subclassed from CLI plugin. And this method of subclassing from the CLI plugin will be an indicator for SR Linux CLI to load this file as a plugin. Now you can see that I have some docstring here that says what this plugin should do. It should add the show uptime command with this particular output that I would like to have. Now, again, this is very simple command. Which only displays the uptime and the last booted time. But for the sake of this introductory tutorial, it makes a perfect example that we can work on. Now, this class that we created, the plugin class, needs to have just one method, the one public method that is named load. And SR Linux CLI expects your class to have this method because this method will be the entry point for the CLI engine to load when you connect with SSH to your device. So now this load method is empty, right? We do not have anything here because we want to write ourselves the show command code and see what it takes to create a command. The load method has this signature. Of course, it expects the self instance of the class, and then it expects a CLI argument and a list of arguments. We will talk more about these and what they do, but this is the common signature for the load function of a plugin. So we will start adding our command to a CLI show tree. To do that, we have to use this CLI argument that will be passed by the CLI engine to every load function of every plugin. And the CLI argument gives us access to methods of the CLI loader class. Now, of course, I do not have any types here, and this is on purpose. I want us to focus on the CLI development rather than working with types. But you will find that the show uptime plugin that we push to the GitHub has fully typed experience with proper type annotation and type hinting. Here I will not use any of that. We will just focus on the actual workflow of creating a CLI. So now I have access to my CLI loader class, and it has the show mode argument. The show mode allows us to get access to the show mode of the CLI. That is what you get when you type show command, right? And I can add a command to the show tree using the method show command. Now, with this add command, I need to provide a few attributes to it. The add command requires you to provide a syntax of a command, a schema, and a callback. Now, we will stop more about on all of these topics, but we will start with a schema. So I will say, with the syntax. I will say syntax equals, and I will create a function or a method called syntax. And in this method, I will define my syntax shortly. So let's see what is a syntax. Well, syntax is the way for you to define the name of the command, the subcommands that it might have, the help strings, and all of the kind of the representation view of your command. Now, to save me some typing, I will just paste a code that is part of my repository. So this is what we are going to do. We are going to return an object of a syntax class. And of course, we need to add this import here from SR Linux syntax, import syntax. And of course, you can imagine that this SR Linux module is part of the SR Linux itself, but we can import it because we are running on SR Linux directly. So we can leverage the imports that our virtual environment, that CLI infrastructure runs in, provides to us. So now my syntax method will return a syntax object. And as you can see, I specify the name of my command. It needs to be called uptime. I have some short help, I have a long help, and I have a help epilogue. So these are the parameters that syntax takes in, and there are more of them. These are just the ones that we are concerned with right now. So with syntax, we define the way our command looks, right? And we provided this syntax as a return argument to our syntax variable in the add command. Okay, syntax is done. What next? Next, we need to define a schema that our command will use. Now, probably that is a complicated topic. And I mean, the schema is something that you would not think you would need when writing a CLI command. Let's first start with, a placeholder. We will have this schema argument, and we will again use the schema method that we will write again shortly. But before we do that, I wanted to explain what schema is and how it plays into this SR Linux CLI ecosystem. The reason we need schema for our CLI command is because we want to model the data that our CLI command will operate on. And having a model data allows us to benefit from the different output flavors our command can produce. And these output flavors will be implemented by the SR Linux CLI engine without us having to worry about them. Now, again, I think this sounds complicated, so let me give you an example. Take a look at this show uptime outputs that we have in our blog post on SR Linux, learn-srlinux.dev portal. By default, when you type show uptime, you will have this kind of key value format presented in the CLI. But because our data that our uptime command operates on has been modeled, we can leverage different formatting options that SR Linux provides kind of in its own toolchain. We can use the as table output modifier. And because we had a model that prescribes what are the keys and what are the values that our command operates on, the stable modifier will be able to create a nice table for you from the data values and fields that we have in our model. Subsequently, we can use the asJSON output modifier and have a JSON output of our show uptime command. We can have the YAML output. We can have XML output. So you get the idea. Because our data is modeled, we can apply generic formatters to it without implementing the way for each and every of them. And this is very powerful when you want to create a command that can be displayed in different output formatting, especially with structured data like JSON, YAML, and XML. You don't want to use print and create those kind of payloads yourself. If there's already an engine that can take this workload and do it for you, you need to leverage that. So, okay, the schema is important. So we need to define a schema. How do we do that? The way to do that is to leverage again some of the functions that are coming with SR Linux CLI, and I will save me some typing, so I will just paste what I have here for the schema method. This is our schema method. We have to import another function from this SR Linux CLI toolchain, so I will import the fixed schema root. Okay, that's great. And now I have this schema method ready. So what it does is that we create the schema root object that is basically just, / the root of our model. And then we add a child element to it. So you can add lists and containers. Because our show uptime command does not have any nested elements and we do not need any keys and lists, we create an uptime container with two fields. Uptime that we will calculate and the last booted time that we will fetch from the CLI. I think it would be quite easy to kind of map this all together using the graphics. So this is what actually happens. When we use this schema method and we create the schema root and add a child, what we instantiate is a schema object. As you can see, this is the root, and then we create the uptime container, and inside this uptime container we'll have two fields, one for uptime and one for the last booted time. So this schema is just prescribing the format of the data that we will work with as part of our CLI command. And next we will fetch this data from the CLI engine, we will populate this data object, and we will print it out. So some interesting things ahead of us. Let's go. Now that we have our syntax and schema sorted out, we can actually try it out. So I just saved my file as it is now. And if I go back to my terminal, I can connect to this SRL node that has been deployed as part of the setup dev env step that we run at the beginning of this tutorial. So this is the SR Linux container that runs on our machines. And have a look at that. If I type show uptime, the time thing is already suggested for me because the uptime command is now part of my CLI. Now, bear in mind that I did not even need to restart the lab. The very second I saved it and I connect to the CLI through SSH, the CLI infrastructure will load the plugin on the fly and will kind of create the command, add this command to the show tree. That is what we did with our add command method under the load method of the CLI plugin. So now if I type show uptime and I hit enter, nothing happens. And the reason is that, of course, we did not add any logic to this command. We just added the uptime syntax command and we created a schema, but we did not fetch any data. We did not populate the data. That is why it's not there. But what is there is the help things that we created for our command. So if I type the question mark sign, you see that all of the help that we added to the syntax with nice emojis is there. So we see that our uptime command and the help strings that we embedded in it are being parsed correctly, and we can show the uptime command under the show tree of the SR Linux. Okay, now to the fun part. We have defined the syntax of the command that shape up the representation layer of the command. We have defined the schema that drives the data that our command will work on. But now, how to actually make this command work, how to calculate the uptime, how to print it out, this is all happens in the callback function. So our add command method takes in another argument, which is called callback. And the callback is a function that is being called every time you execute the command. Not when you load the plugin, but when you actually type show uptime and hit enter. That is when callback is being called. So we will have this callback function, and the function that you will call, you can name it whatever. For the show commands, it makes sense to kind of name it print something, because we have a very simple command that just prints the uptime. We can say we will write a function that is named self._print. So the underscore print function, we will need to define this, right? Now the callback function has a few things that are worth calling out. As you can see, the callback function has a certain signature. It received the state attribute. The state attribute gives you access to the state of the CLI or state of the SR Linux in general. You can use this state argument to interrogate the SR Linux state and get the values out of it, like if you would do with info command from state, for example. You also have the output argument. The output argument is the argument that you will use to print things to the terminal. The body of this callback function is kind of universal, but it is up to you what you want to do within your main logic of the command. In our case, what I will use here is I will create a fetch state function. That is the function that gets the state from the SR Linux state tree, because we need to find out a leaf that contains the last booted time, so we can calculate the uptime as the current time minus the last booted time. And once we have this information from the SR Linux state, we need to populate the data. Remember that we created the state schema. We created the schema that defines the data that we work with. Now we need to populate this data that is driven by the schema so that the output can be printed from this. Then we will have something interesting called set formatters. That is another interesting way that SR Linux offers to you. The representation of your data can be customized. It can be a table, it can be a tag value formatter. You can have different decorators around your data. So set formatters is the function where we will define all that. And finally, we will print the data out to the CLI, and you will see how it all kind of maps together. First, we start with the first step, fetch state. This is the function that needs to query the SR Linux state and find out what are the leaves that we need to take from the state for our show command to work on. Now, in our case, the show's uptime command literally displays two fields, the last booted time and the uptime. Now, you might already kind of guess that we need to find a leaf that displays the uptime, that displays the last booted time of the SR Linux system, because that will be our point of reference when we calculate the uptime, because the uptime is just the current time minus the last booted time. How do you find a leaf that contains the value that you need to have in your main logic? So one of the ways you can find a path to a leaf that contains the information that you're looking for is by listing the full tree from the state data store, the state CLI mode, and grab for the parameters that you think would be encoded in the path somehow. So in SR Linux, we have this tree flat command that lists all of the commands in a flat format, line by line, expanded down to the last leaf. And I can do this from the state CLI mode, so I can have all the state elements as well. But I also know that probably this path will contain something like lost, because I'm looking for the last booted time. And I will also grab for boot, because that would be the boot time or boot something. This is another keyword that I'm looking for. So if I use this tree flat, you will see that SR Linux management server will stream back for me everything it finds, every path with the last and boot keywords in it. And as you can see here, the last line is system information last booted. So I can do info from state, and yeah, look at that. That is actually the information that I'm after. That is the time in the UTC format. I could use that as my reference point to calculate the uptime. What I could also have used is the SR Linux Yang browser, and that would be my choice because I like the UI experience that it offers. And I can type here in the path browser window, like same keywords, last and boot, and I will find the exact same paths, but now it's kind of more easy for me to eyeball them and change my query as I go. And I will find this system information last booted as well. So this is the path in the XPath-like notation that I could use. So now we know the path that gives us the information for the last booted time. Let's use it. So here is how we would use the system information last booted path and fetch the state from SR Linux CLI. We create this fetch state method, and we need to build a path from the path information that we just discovered. So the path information as a string in this XPath notation needs to be converted to the object that SR Linux management server could use. For that, we need to have this build path function that again comes from the SR Linux CLI toolchain. We can import it from a CLI location. And the way we use that is that we use the state argument of our method. And as I said before, the state gives you access to the server, the management server of SR Linux, so that you can query the data. So we access the server data store, and we get data using the path that we just constructed, the last booted path. We have retrieved the last booted time, and we save it under the private variable of our plugin class. Great. Now we need to make sure that we make some useful stuff with the information that we just retrieved. All right, so our next step is to populate the data that we retrieved from the state CLI mode. We need to make sure that we populate this data that we modeled with a schema before so that it can be printed out later. So I will create this populate data method, and it takes in these arguments that we pass over here. What we will do in this populate data method is that we will create the data object. So the data object is our way to instantiate a data container from the schema that we created earlier. For that, we have this data class that SR Linux offers, and it takes in this schema argument, right? So schema equals arguments schema. So we make use of the arguments parameter because schema is part of the arguments for every command that we pass on. And now we have instantiated this data object. We need to import the data class, of course, first so that we can have access to it. Now we imported the data. It should be all good now here. So what happens is we created a data object from the schema. We basically instantiated a schema, which was just a way for us to describe the data container with our uptime and two fields in it. And now we instantiated an empty container that is modeled after the schema. But it's not all. We need to kind of create this uptime container inside this data object. I will just copy paste it from the repository to save on some time. So the uptime container will be created by calling the uptime attribute of the data object and then calling the create method. This is actually what happens. We had our schema that defines the data that our show command will work on. And now we need to create an instance of this modeled schema. So we created the data object first, and then we needed to create the uptime container. So remember, we had this uptime container modeled in a schema, but to create an empty container, we needed to call this data.uptime because the uptime is the name of our container from the schema. So we can access our ancestry tree by using the names of the attributes as we define them in a schema. So data.uptime, and then we call the create method to instantiate the container. Okay, now we need to set the values in our uptime container to the values that we need our show command to show. And these are two values, the last booted time and the uptime. The last booted time, we already fetched it from the state of our SR Linux system. So how do we set this value to the uptime container that we just created? All right, now that we have our uptime container instantiated, it's just like an empty vessel. We need to set the fields, the last booted and uptime, to the values that our show command needs to show. First, we can start with the last booted value because we fetched it from the CLI state already. The way it works in SR Linux is you take in your uptime container data object and you access the field inside of this container. Remember, the container has two fields, last booted and uptime. And we can already set the last booted to the value because we fetched it from the CLI already using the state attribute here, right? That is where this part happened. So you have this root object that is your data store, and then you go and say access the system container, and we go here with this system.get. So now we have the access to the system container. Inside the system container, there is an information container. So we do get .information.get, and we go down to the information container. And inside of this container, there are different fields, and one of them is last booted. So we just use the dot notation to get to the last booted attribute, and that is how we get the value of the last booted as a string. Okay, sweet. So now we have this last booted field saved and set into the uptime container data. Now we have just the one thing left is to calculate the uptime. And we can do that using this calculate uptime function that I will just copy paste shortly, but you get the idea. We access the uptime field under the uptime container and we set it to the value that we want it to be set to. Now in our calculate uptime, we will pass over the last booted field, and in this function we will just calculate the uptime. So this is the calculate uptime that just calculates the uptime based on the UTC date of the last booted. So we do get the current time using the UTC time zone, and then we subtract the boot time that we passed over to the function. I need to import some stuff to make sure that it all works, and this comes from the Python standard library, so I don't have to worry about any of the extra dependencies. So I add the time zone and date time packages, and now my calculate uptime function should work as expected. So now that we have this calculate uptime created, we need to return the data that we have instantiated at the beginning of the populate data function. So we created the data container, we access the uptime container in it, we created the container from the schema, then we set the values of this uptime container with the fields that we subtracted, or the fields that we extracted from the SR Linux CLI, and then we calculated the uptime, and then we saved it in the uptime container here as well. Now the populating data is done. We actually completed the most complicated part of this CLI tutorial. We fetched the data, we populated the data, we played with the schema, we created the syntax. All is left is just to print it out. To print the data out, we have to complete two steps. We have to put in some formatters around the data so that we drive the way the data is presented on the CLI, and then we need to print the data out. These are the two steps that we have to clear. I will first start with the set formatters. So we need to define a function or a method that will set some formatters around the data that we have created and populated. So let's go to this function here. I just pasted it. The set formatters is a function that adds a formatter class to different mount points of your schema. So you see that there is this data set formatter method that expects you to provide a schema path and a formatter that will be applied to this path. Recall that our data object has this uptime container, and this uptime container contains two fields, last booted and uptime. We can apply a formatter to a container or a list, and uptime is our container. Now, what kind of formatters can we use? There are different formatters that SR Linux CLI comes with. One of them is tag value formatter. That is basically your key value pairs nicely displayed with, occupying the full width of your terminal. And we can also use these border decorators that will allow us to create nice borders either at the beginning or at the end or above and below together. So we use these two formatting classes for this particular function. In our documentation at learn-srlinux.dev, we will cover different formatters and how you can use them, together, or how you can mix and match them, as well as how you can create your custom formatters. Because sometimes this tag value formatter or table formatter does not work for the complex data that you would like to print out. And that is when the custom formatters would make more sense for you to invest your time into and create this nice layered representation of the data that you would work with. Now I need to import some stuff to make it work. So I will import the border and the tag value formatter. And now my set formatters is not complaining anymore. It should work. It has all the imports resolved. And that is how we set the formatters for the uptime container in our show command. Last piece in the print callback function was actually to use the output argument and use the method print data. We don't need to do anything here. It's the function that comes with SR Linux CLI, and we can just use this. We pass the data to this method of the output argument so that the data can be printed out. Because the data is modeled and we set up the formatters, it will be displayed in a certain way. So let's see what we have now. I will just save my uptime Python file, and let's go back to the CLI. Now, when I'm in the CLI and I just saved my uptime Python script, if I try to run it right away, nothing will happen. And the reason is that your plugins are loaded when you open a CLI connection, when you basically start the CLI engine. So what I will do is I will just disconnect and connect again. So now my CLI plugin has been reloaded, taking in this last saved state that we have. And if I type show uptime, hey, look at that. We have this nice representation of our uptime with the uptime field set to the calculated uptime in the human readable format, and the last booted field set to the UTC value of the time that the system has been last booted. So this value is actually the value from the last booted field. So if I do info from state system information last booted, this is exactly the same value, right? Because we fetched it from the CLI state directly. And then we just calculated the uptime in this human readable form so that it is easier for a human to kind of figure out how long ago the system has booted. Now, remember, the struggles we had with schema were not for nothing. We can do show uptime and do as table. And then our command will be printed differently because of the modeled data structure that we work with. We can do as YAML and have our uptime and last booted data nicely printed as YAML. So we have this uptime container that comes from our schema, and then two fields, uptime and last booted. And of course, same goes with JSON, etc., etc. So now you can see how you can write your own commands using the CLI, SR Linux CLI plugin infrastructure. We, of course, just scratch the surface because there are many more things you can do with it. It was a very simple example, and yet we spent quite a lot of time going through it because I wanted to explain every bit of every component that goes into the CLI programmability development experience. But now you can open up all of the existing CLI commands that SR Linux ships with and look at how they have been created. Look at the custom formatters that we use to display more complex stuff like BGP, EVPN tables and things like that. And maybe that will give you some inspiration to write your own more complicated show commands. It's now your turn to figure out what you want to add to the SR Linux CLI. I hope that you will find it quite useful, and whenever you have something to share, go to our Discord and tell us more about your CLI experience. Till next time, thanks.